I didn't want to run right in front of you.
I mean, they also get the fan questions.
Okay, mic check 1 2 1 2 1 2. Welcome back to our channel, everyone. Thanks for the hiatus while we waited. Sample return capsule was safely packaged up in the correct materials to load it onto the helicopter. That has just officially been loaded onto the helicopter and is going to be coming from the direction to our left here. We're going to see that capsule fly by. Since we couldn't quite see it on our last stream, the scale size was quite small and we need a really high power zoom lens. So hopefully we can get that for you guys. Maybe we get some better lenses, and I will be making some shorts and some videos. We're going to get the B-roll footage from NASA for the up close. Only a very few limited of the NASA press was allowed to be at the actual landing location. We're here at Dugway Proving Grounds in Utah. The location where the SRC, or the Sample Return Capsule from NASA's OSIRIS-REx, is off to our left for a few miles. We've got the media crew all lining up here again. And just a reminder, this is the first American asteroid sample from the asteroid named Bennu, which is a near-Earth asteroid, or an NEA, specifically chosen because it was an NEA, and also that it's carbonaceous and holds some of the most primitive solar system materials and minerals within inside of it. So what will happen next is we'll get the flyby with the capsule dangling down from the helicopter. We'll watch that for the live stream, and then they're going to head on over to the Dugway clean room for the first stage of securing the sample. Then eventually it makes its way to NASA Houston, back in our beloved Texas, and we'll be live streaming the opening of some of the samples on October 11th. So you can stay tuned for that as well. So I'm going to go ahead and pop behind and see if y'all got any questions while we wait. All right, we got some of the first helicopters flying by here.
It's carrying something underneath it.
Oh, that's it way over there. This is another helicopter that's landing. This is where the clean room is. So for U.S. government purposes, I can't pan more than to the right of here, but they are heading to the Dugway clean room. So this is Dugway, Utah. It's a very remote location, proving grounds where a lot of U.S. testing for such things can occur. So that's the first helicopter in. And we're looking for the one with the capsule dangling from the bottom. Let's get back over here and see if y'all got any questions yet.
Everybody fits in one. And I can just follow you here. It's over there in the Avery. Now that's really weird. Also,
Okay, so for those of us joining us again, this is our live coverage of the NASA OSIRIS-REx Asteroid Sample Return Mission Recovery. We've gone to Asteroid Bennu, carbonaceous asteroid in our solar system, grabbed a sample and returned some of the material here. Oh, we got another helicopter coming. I'm going to hand to that. Yeah, I got word that the helicopter is coming soon, so we're going to make sure we watch. This is the sample return capsule that will be brought over from a helicopter from its recovery location. It took about an hour and a half for the NASA team, the recovery team, to first off find it in the Utah desert, which is out to our left several miles off, so we're not at the exact landing location for safety reasons. But we're over here at the helipad where the sample return capsule will then first be brought over to the Dugway clean room. There were many checks and balances to make sure that the lithium disulfide battery wasn't outgassing, and they had to wrap it up in thermal. So the capsule is currently all nice and bagged up in a lot of space blankets, essentially. And we're waiting for the helicopters to return, one of them with the SRC, the sample return capsule. NASA's OSIRIS-REx, first asteroid American sample return. So this is a sample, and it's, hey, not such a little sample. The canister that filled the material from asteroid Bennu had so much material spewing out, they actually had a hard time closing the sample door. So the goal of the mission was to secure at least 60 kilograms of material. Secured more than this. The sample, the carbonaceous material of Bennu, is going to be sent to 17 universities and institutions around the world for the science and discovery and analyzation for the materials over the next coming years. So from where the sample recovery location was about a 10-minute flight. So I started the live stream just about where they should have been starting the rendezvous back here. Again, we're out in the Dugway Proving Grounds, a very remote location in Utah. And the SRC deployed its parachute successfully. It hit the atmosphere. after spending 4 hours in the vacuum of space without OSIRIS-REx spacecraft. The OSIRIS-REx spacecraft let go of it this morning, and for 4 hours, the SRC flew through the vacuum of space at 8:41 a.m. local time here in Utah. It touched the top of the atmosphere and struck the Utah desert at 8:52 a.m. They recovered the parachute first. Again, this is all off to the left, or where I'm kind of panning here, off to the left where the sample recovery site was located. They used some high resolution to find it in the Utah desert. Then they had to do a series of testings to make sure that nothing like the battery was outgassing, and wrap it up in a lot of thermal blankets and get it on the helicopter. They're going to pass right here and then bring it to the Dugway clean room. The Dugway clean room, I'm panning to it now. Here. I was told, I believe it's this taller building here. There we go. It's the Dugway clean room. That's where the sample return capsule will be flown to first. Then it will be sent to NASA Johnson, located in Houston, Texas. Eventually, they'll open all the samples and it will be dispersed to 17 universities and institutions around the world. All right, so we're just waiting for the helicopters to all arrive now. They should be en route. So hang tight. Let me see if y'all got any questions. Okay, so I saw some great questions. How will OSIRIS-REx and DART learn off one another? So DART is the double asteroid redirection test. So this was the Armageddon of asteroid tests, where NASA slammed the DART spacecraft into the binary asteroid system Didymos and Dimorphos. And so the idea is that we can measure the angular change as these two binary asteroids orbit around another. Here's some helicopters. Okay, we'll answer more questions in a moment. Let's go ahead and get this. I see it. There it is. All right, let's zoom in. There it is. On all its glory, at last, YouTube channel. We've got it. So there it is. There's the helicopter. There is the SRC hanging below, en route to the Dugway clean room. America's first asteroid sample. Flying high. So it's wrapped in thermal blankets. Oh, this is awesome. All right, the fish hook is empty. It has been officially delivered. So again, that was that sample return capsule wrapped in thermal blankets tethered on this helicopter that I've got in frame there. You can still see the tether hanging down. Okay, so the recovery helicopter has landed, and now I'm panning to the NASA helicopter. This is the same NASA helicopter that the astronauts use to train in. The NASA helicopter gets a lot of mileage. We'll actually be releasing a video. I got to get behind the scene tours of this a few weeks ago. We'll release a video on this helicopter specifically. You pay taxes in the United States, your tax dollar is hard at work, people here. 17% of 1 penny of every U.S. tax dollar federally goes to NASA. It's a good 17% of 1 penny, if you ask me. And so they also had some media coverage from that NASA airplane. So we'll be getting some nice B-roll footage for y'all so that we can see that sample falling through the atmosphere with greater clarity with some bigger zoom lenses. So again, the sample return capsule for NASA's OSIRIS-REx has been delivered successfully to the Dugway clean room. That's what's where the NASA helicopter is hanging out here. Dugway clean room is off in the distance here. It's this building. The sample return capsule is safely inside where the first inspections inside the clean room can occur. And again, the material was very over full. They got well over the targeted 60 kilograms of material, and it will be subdivided out, and over the next few months be flown around the world to 17 different institutions and universities. The last thing that might occur on this is we may get the PI of the mission, Dante de Loretta, to pass by. We heard he might. We'll give it a few moments here. If he doesn't, we'll end the live stream with a few questions, but we'll see if we can get Dante to pass by here. The man behind the work, or well, the lead man behind the work. This is a huge mission. OSIRIS-REx was first designed and submitted to NASA as a proposal in 2004. It was rejected. They redid the work and submitted it in 2005. It was rejected. They did it again in 2007, rejected. And they did it again in 2011, and it was selected. So it's an over 20-year mission endeavor to get the pristine sample. Woo, thank you, recovery team. All right. Look at the recovery team people passing by. The ones on the ground out there. Pretty cool. All right. Okay, so we're going to keep this view here for a moment. And
Oh, well, that is where. Okay, so that's it, right? Oh, that's it. So they've already done it. Yeah, yeah.
oh,
I think they were planning on it. Well, I mean, it's very big. Oh, is it? Okay, sorry. No, you're okay.
okay, NASA helicopters officially landing now. Again, these sample return caps delivered to the Dugway clean room. Everyone's landing. We've got the sample recovery team passing by, the people that were on the ground out there checking on it. Local celebrities here. Again, the sample is now in the Dugway clean room. I'll zoom into it now. This building.
Yeah, they're like, where are you? I thought you were up in Scotland. Yeah, I know.
All right, let's see if y'all got some questions. That was pretty cool. Luckily, our lens had the right zoom for that distance, so we'll have to get some high zoom lenses for really far away filming stuff. I could even barely see it with my eye for our first live stream this morning. We'll be getting some B-roll footage of NASA. We'll make some videos for y'all.
Anything going on in there right now? Yeah, I do. Anything going on in there right now? Spencer's plan is like basically
Okay, I see in the comments that y'all like love aliens, so of course that's fun to speculate. Aliens jumped out. Hopefully, no noxious gases. We open the asteroid sample. These are materials that are mostly of carbonaceous nature, but there's hydrated silicates material in the Bennu sample. There's calcite veins, there's pyroxene chunks, a bunch of geologic terms that sound like jargon, but essentially there's a bunch of different minerals in the asteroid Bennu. I saw a question asking about the size. It's 1,700 meters wide in diameter. This is a 3D printed model of it, and yes, it is oblong shaped like that, so it is a funny shaped little guy there. The touch and go sample acquisition mechanism, TAG-SAM, is what grabbed that sample on October 10th, 2020. The canister was to hold at least 60 kilograms of material. They got that. That sample was closed, and it's been closed since that day and is all the way over there, that Dugway clean room. The next steps are to extract it out of the capsule, get it to NASA Johnson in Houston, and then there are 17 different universities and institutions around the world that get the sample material. Again, it's all of carbonaceous nature. It came from a carbonaceous asteroid. Asteroids are what I like to call the crumbs of the solar system, the debris, the leftover materials that just didn't quite into the planets that we formed, that we know and love. And so some asteroids, as they feel the gravitational push of the mass of Jupiter, get kicked into the inner solar system, and they become near-Earth asteroids. And if they get really dangerously close, we call them potentially hazardous asteroids, or PHAs. Now, Bennu was chosen because it is indeed one of these asteroids. It intersects our Earth orbit, deeming it a near-Earth asteroid, and became of high for the target selection criteria so that we could better understand and better refine the orbit and better see, you know, if we got up close and personal, if we understood more of the gravity and the materials that it's actually made of, then maybe we have a better understanding for trying to mitigate risk for here on Earth. There was a question for how is OSIRIS-REx going to, or how could OSIRIS-REx and the DART mission, NASA's DART mission, work off each other? Well, they really can, because we got high resolution maps and images of the asteroid Bennu. It really helped refine the orbit, and we did a completely different type of mission where instead of grabbing some material, we just hit the material. DART, the double asteroid redirection test, was to see if we can change the angular momentum. So I would assume that there'd be some modeling that we can use to understand how the changes in angular momentum and maybe the fine-tune data that we got for the orbit of Bennu could work off each other. I'm no modeler, but I assume that there's some good modeling that could be done from learning these sort of fine-tune differences in orbit. To even define an asteroid, it has to be observed at least 3 times. And telescopes on the ground do this typically. There are telescopes in space for this. For instance, the NEO-WISE and the up-and-coming NEO-SURVEYOR that looks at asteroids in the infrared, but they can only get to a scale size. And so it's actually good to use optical telescopes to look for even smaller asteroids. In fact, NASA's Planetary Defense Coordination Office, PDCO, which is the group that headed the DART mission, actually has a huge campaign to search strictly for asteroids that are 80 meters in diameter and less, so way smaller. So it's just about 1,700 meters wide for our asteroid Bennu. But we really want to know about really, really teeny tiny ones, because really teeny tiny ones, if they hit in a certain area, could still cause a lot of damage. And let me see if I can take one more question here.
Fingers crossed we don't have to do that. What are you doing?
Okay, so the last two questions that I'll answer here in the live stream before we cut it is what will happen to the sample now and who owns the sample? These are really great questions. And so this is a NASA-funded mission, and so that means you and I, as U.S. citizen taxpayers, pay your taxes in the United States, your federal taxes. We essentially paid for this. So it is owned by the people, by the American population, essentially. That, you know, if it's a federal agency, and so our taxpayers pay for this federal agency, and that means that and this goes for any meteorites and samples. You can actually request all this data from NASA. You go on their archives. It's all part of it being a federally funded agency. So NASA owns it, but technically, you know, you and I all equally own it as well in that regard, because that's just kind of how the NASA funding works. Again, 17% of 1 penny. So when you pay taxes and there's like 1 penny out of a whole dollar, you know, take that 1 penny and 17% of that, and that's what goes to NASA. So believe it or not, it seems like not that much money, but we can really get a lot done with this. And so the sample of the asteroid Bennu is going to now head to Texas today. They're going to finish what's up they got it in the clean room over here at Dugway. They're going to get it out of the heat shield and then load it up, get it to NASA Houston, and then they will then also in clean rooms at NASA Houston open it up even further, the actual capsule that's inside, the actual canister that's inside the whole capsule, and then it will be divided out. NASA will be at Houston as the main curator, so they're in charge of dividing out the sample, but it goes to 17 different locations around Earth, one of them, of course, being where the mission is based out of, the University of Arizona in Tucson, Arizona. This was the largest amount of mission and money and funding that has ever come through the University of Arizona's doors, so it was a huge undertaking and a fantastic, I've been volunteering for the mission for 11 years now, but it's over 20 years in the making. And I'll just do one final quick check. Okay. That wraps it up. So yeah, it doesn't belong to a private company or anything like that. It belongs to different institutions and universities all around the world. Stay tuned for the science papers that will come out. And technically the spacecraft isn't done yet. So the next thing you can follow along with is the revamped version. So the OSIRIS-REx spacecraft still has fuel, still has power, can still keep on trucking in the solar system, and is headed now to the asteroid Apophis. So right now, PI Dante Loretta has completed his part of the mission, and the new PI Danny De La Gustina has taken over for Apex-REx. Stay tuned for the mission as it goes to the other potentially hazardous asteroid, Apophis. And they will not return a sample from Apophis, but they will get high-resolution images and data and radar and orbit refinement, all that cool stuff. And you can follow along with that on asteroidmission.gov, nasa.com. And then for us, we'll be doing a bunch of recap videos, and we'll also be in the room in NASA Johnson, October 11th, right here, back on YouTube for you all. I'll be at NASA Johnson in the Ares lab, and that is where we will then get a closer view of the carbonaceous material itself. Thank you all for tuning in twice for our double live stream feature. I'm Dr. Allison McGraw. Don't forget to gig 'em.